at the UPS Distribution Center in Plainfield, Indiana. We've got gas detection system and heating and cooling. So we'll be monitoring for CO and NO2, exhausting the space as needed for life safety. And then we're also doing space comfort for all the office areas. So we've got 10 rooftops throughout the area that are feeding fresh air into the space in response to the CO and NO2 systems. And then we have 7 heating and cooling systems that are serving the office areas. So right here we've got a makeup air unit that's feeding fresh air into the space in case of a CO or NO2 event. It also has a built-in heater to make sure that in the winter we're not dumping negative 10-degree air on all the occupants. Inside here we have a BACnet interface card. Each one of these large units on the roof has a BACnet card. And from there we can see the space temperature, space pressure, any kind of information we want out of the unit and control it, enable it, disable it, go from there. So we've got a rooftop unit here that's serving the office area. From downstairs we'll be able to adjust the thermostat and send the commands kind of like you would do at home. However, this will be accessible over the internet. Somebody will be able to pull it up on their phone, see all the units in the entire building, make temperature adjustments real quick and easy from wherever they're at. So we've got our Distech controller right here. It's tied in with the main circuit board to enable the heating and cooling. We've got our temperature sensors for the discharge on the unit so you can see what it's actually performing. We've got a communication wire that's running from each unit in the building in a daisy chain fashion so you can see it on the front end on the computer side. From the main circuit board we've got a couple of contactors that we're energizing to bring on the heating and cooling, and then our gas valve down here. These sensors will read a value 0 to 2,000 parts per million back to the panel, and from there the panel will decide how to interact, what fans to bring on, and how to basically evacuate the space as needed. We've got 64 CO and 64 NO2. CO would be for a typical gasoline engine. The NO2 would be for a diesel engine. So this is a Q controller. It talks Modbus to all the sensors in the area, and then we have a Modbus communication inside of here going out into our Tritium panel. From here you can see the Tritium panel can communicate wirelessly. You can pick it up on your phone and see all the values in the space. We've got all of our exhaust fans here. We installed a relay on each one of these. The panel we looked at earlier will energize this relay, bring on the exhaust fan to make sure the air is clear. This project had about 300 man-hours throughout the entirety, including installation, engineering, commissioning, and startup. We have about 128 sensors on site. If you were looking at a similar project, the power of this system is that it's flexible. This building, while we're going to turn it over and it's going to be complete, has room to grow, and they've already contacted us about future installation options. So we'll be able to build on what we already have without having to start from ground up and have a really expensive system all over again. Thanks for joining us here at the UPS Distribution Center. If you want any more information on a gas detection system like this or anything else, you can reach us at 317-308-8678. Thanks.